Welcome to all my dear students. This is chapter number 2, mechanical properties of fluids. Now in previous lectures we are good familiar about the first important part from this chapter, that is pressure, and after that pressure, now we are discuss the next concept from this chapter. Actually we know that mechanical properties of fluids are classified mainly two types, because we know what is fluid. Fluid is the substance, it can be flow. Okay, so flowing substance is called fluids. So this definition we are good familiar about this. Now according to this, the mechanical properties of fluids are classified mainly two types. Now which one? Let's see. The mechanical force and their two types. So mechanical force, their first important type is hydrostatics. Okay, and the second type of the chapter is hydrodynamics. Okay, there are two parts from the chapter. So what is meant by hydrostatics? So hydrostatics is the study of fluid at rest. If the fluid becomes rest, okay, so all that properties of fluids we are discussed within the part of hydrostatics. And when the fluid is in motion, okay, so such concepts we are discussed with the help of hydrodynamics. So hydrostatics means the fluid at rest, and hydrodynamics means the fluid in motion. But according to the hydrostatics, we know that this hydrostatics again classified mainly two ways. So between hydrostatics, initially we have discussed the concept of pressure. If the fluid becomes at rest, so what is the concept of pressure? And after that we have discussed surface tension. That is very important part from this chapter. Okay, surface tension. And here we have discussed the fluid in motion. So it means that the whole chapter is divided mainly three important parts. So between this, the first part we have discussed, that is pressure, the second part we have discussed, that is surface tension, and third part, that is fluids in motion. There are three different stages from the chapter. So now in previous lectures, all the concepts related to the pressure, what is the definition of pressure, what is the different units of pressure, what is the dimensional equation of pressure. Now after that, what is the pressure due to the liquid column expression. After that we have discussed the concept of atmospheric pressure, what is the absolute pressure and gauge pressure. After that the concept of pressure, we have discussed the hydrostatics paradox. After hydrostatics paradox, now we have discussed Pascal's law and their applications, and finally we have discussed some instruments. By using this we are trying to measure the atmospheric pressure. It means the instrument such like used to measure the pressure. Okay, and after that successive concepts, now today we are started one another very important concept from this chapter, that is second part from this chapter according to hydrostatics, that is surface tension. And this surface tension is very important part from this chapter. Okay, so that's why descriptively each and every point from this chapter we are trying to discuss. So let's start it. The first important point from this chapter, that is surface tension. Let's start it. Surface tension, that is very important. Okay, because when we discuss about our board examination, now this chapter has maximum 5 marks and with option 7 marks. This is the weightage according to board examination, and according to CET, NEET or JEE, comparatively near about 2 to 3 questions on the same chapter. Okay, and between this, near about 80% chapter, it is more chance, near about 80% questions are asking on the same concept, that is surface tension. It means the concept of surface tension is very important for the study of mechanical properties of fluids. So let's begin the concept of surface tension. So before we started the concept of surface tension, before we discuss about their definition of surface tension, it is very important to know that what is molecular theory, and with the help of this molecular theory we are trying to discuss the definition of surface tension. So let's begin the molecular theory. Now initially from this chapter we have discussed the molecular theory. Okay, so molecular theory. and with the help of this molecular theory we are trying to discuss what is meant by surface tension. Okay, and between this molecular theory we are discuss some important definitions. So let's start it simultaneously one by one. The first important definition according to molecular theory, so this definition is intermolecular force. Okay, intermolecular force, this is first important concept according to molecular theory. So what is meant by intermolecular force? Intermolecular means what? It is a force between molecules. Get it clear? Because we know that when we consider any solid substance, any matter we are consider, so matters are made with large number of smallest elements. And when such all that smallest elements, smallest particles are coming very close together, it will be attracting together, so we get the solid substance. So why the all molecules are attracting together? Because their responsible force is intermolecular force. Okay, it means that intermolecular force is the attractive force between two or more molecules. Okay, it is a force of attraction. What is intermolecular force? So intermolecular force is the force of attraction. It is a force of attraction between the molecules. Okay, between the molecules, and that's why the solid substance are made. That is very important definition. Okay, now what is intermolecular force? It is a attractive force. Okay, it is a force of attraction between two or more molecules. You got it clear? Now this intermolecular force is classified mainly two types. That is very important. Now intermolecular force is classified mainly two types. The number first cohesive force. Number first cohesive force, and number second adhesive force. Okay, so cohesive force and adhesive force is the parts of intermolecular force. So let's discuss what is meant by cohesive force and what is meant by adhesive force. So which force is called cohesive force and which force is called adhesive force? Now initially we have discussed the cohesive force. Now force of attraction between two molecules. You remember this? The force of attraction between two molecules of same substance. Let's write here. The force of attraction between two molecules of same substance is called cohesive force. Okay, it is a force of attraction between two molecules of same substance. Same substance means what? The force of attraction between two air molecules, both molecules in air. Okay, the same substance molecules are attracted. The responsible force is called cohesive force. Now the force of attraction between two solid molecules. The two molecules are solid. It means same substance molecules are attracting together. The force of attraction between two molecules of liquid. Now liquid molecules are attracting. It means same substance molecules are attracting together. The responsible force is called cohesive force. Okay, and after that the concept of adhesive force. So which force is called adhesive force? Let's begin the definition. Now the force of attraction between two molecules of different substance. The force of attraction between two molecules of different substance. It means the force of attraction between two air and solid molecules, the force of attraction between two air and liquid molecules, the force of attraction between liquid and solid molecules. It means two different substance molecules are attracting together. The responsible force is called adhesive force. And same substance molecules are attracting together. The responsible force is called cohesive force. Now according to near about 80% concepts in surface tension is depends upon these two important definition, that is cohesive force and adhesive force. So that's why the definition of cohesive force, adhesive force, and that is very important difference between two. What is important difference between cohesive force and adhesive force? So now the same substance molecules are attracting between cohesive force, and here the different substance molecules are attracting. Get it clear? Okay, you remember this, that is very important definitions when we discuss about surface tension, because 80% concepts are depends upon these two important definitions, cohesive force and adhesive force. We are remember once again, what is cohesive force? The force of attraction between two molecules of same substance, and adhesive force means what? The force of attraction between two molecules of different substance. Get it clear? Okay. So this is first important concept according to molecular theory, first important definition according to molecular theory. So let's discuss the next important concept according to molecular theory. Okay, according to the molecular theory we are discuss next and very important. Now second concept according to molecular theory, range of molecular force. Okay, next concept, range of molecular force. So what is meant by range of molecular force? Let's begin the definition of a range of molecular force. Let's see. The maximum distance between two molecules of the maximum distance between two molecules up to which the intermolecular force is effective. Okay, what is meant by range of molecular force? The maximum distance between two molecules up to which the intermolecular force is effective. Let's imagine there are two molecules. Imagine that this is our first molecule and there are second molecules. Okay, initially the both molecules are separate. Now what happens when the intermolecular force is effective? When the intermolecular force is effective, now these two molecules are come very close together, okay, it will be attracting together. Get it clear? Now when the intermolecular force is effective, now the maximum distance between two molecules up to which the intermolecular force is effective. So we know that when the intermolecular force is effective, these two molecules are strongly connecting together, strongly attracting with each other. Actually, practically we don't see the gap between two molecules through the open eyes, but now when we shows that these two molecules after the intermolecular force is effective in electronic microscope, so simply we are shows that now these two molecules are just separate. Okay, these two molecules are just separate. Now such maximum distance between two molecules up to which the intermolecular force is effective, such maximum distance is called the range of molecular force. When the intermolecular force is effective, so molecules are strongly connecting together, but they are having a small gap between two. Okay, such a gap is called range of molecular force. The maximum distance between two molecules up to which the intermolecular force is effective, and such gap is 10 raised to power minus 9 meter, that is 1 nanometer is the range of molecular force if the intermolecular force is effective. That is very important. What is the gap between two molecules if the intermolecular force is effective? So such gap is 10 raised to power minus 9 meter, that is called range of molecular force. Get it the clear? Okay, what is the range of molecular force? It is the maximum distance between two molecules up to which, okay, up to which the intermolecular force is effective. Okay, and such range is called 10 raised to power minus 9 meter. That is very important. Get it clear? Okay, so let's see the next concept, next definition from this chapter. Third definition after range of molecular force. Now sphere of influence. Okay, the next concept is the sphere of influence. So what is meant by sphere of influence? Let's see the definition. The definition of sphere of influence. the imaginary sphere is drawn around the molecules. Okay, the imaginary sphere is drawn around the molecule whose radius equals to the range of molecular force. This is the definition of sphere of influence. So let's discuss what is sphere of influence. The imaginary sphere is drawn around the molecule. Let's imagine that any one molecule, any one smallest particle of the substance. Let's begin here. Imagine that this is any one molecule. Okay, this is any one molecule, very small particle, and around which we are consider the imaginary sphere. We are draw an imaginary sphere around the molecule. But when we draw the imaginary sphere, now whose radius is equal to the range of molecular force? It means whose radius is equal to the 10 raised to power minus 9 meter. Okay, that is very small. So according to this, you just imagine what is the size of the particle, what is the size of the molecule. You get it clear? So this is very, very small. Now the imaginary sphere is drawn around the molecule, but whose radius is equal to the range of molecular force. So such imaginary sphere is called sphere of influence. Get it clear? Okay, this is third important definition according to the molecular theory. So after the sphere of influence, one another important concept we have discussed, that is surface film. Okay, can I rub this? Okay, next concept is surface film. The next important concept according to molecular theory, fourth concept, surface film. That is important. Okay, what is surface film? Let's discuss the definition. It is a free surface of liquid. Okay, it is a free surface of liquid whose thickness is equals to the range of molecular force. Okay, whose thickness is equal to the range of molecular force. Let's see the definition. It is a force. Okay, sorry, it is a free surface of liquid. What is this? It is a free surface of liquid whose thickness is equal to the range of molecular force. Let's see here. Now imagine this is any one container. Okay, and just we take a liquid from this container. This is a liquid. And imagine that this is a free surface of liquid. Okay, this is free surface of liquid, and which is denoted by xy. Xy is the free surface of liquid, and just inside the liquid we are draw one another parallel line, that is x dash to y dash. This is a parallel line just inside the liquid. Let's imagine that this is a free surface of liquid whose thickness is equal to the range of molecular force. It means the distance between y to y dash or x to x dash is r, and this is equal to 10 raised to power minus 9 meter. That is very thin. Okay, it is a free surface of liquid, but whose thickness is equal to the range of molecular force. So such a thickness is called surface film. Get it clear? The concept of surface film. It is a free surface of liquid, but whose thickness is equal to the range of molecular force. Range of molecular force means what? The distance is exactly equal to 10 raised to power minus 9 meter, that is 1 nanometer. Okay. Now after that, one another important definition we have discussed according to molecular theory. Fifth concept we have discussed according to molecular theory. Okay, fifth concept, and this concept is free surface of liquid. Okay, last concept according to molecular theory. Now free surface of liquid. So which surface is called free surface of liquid? Now that type surface, okay, it is a free surface of liquid, but this surface cannot experience any shear stress. Okay, now it is that type surface, so this surface cannot experience any shear stress. Okay, this surface cannot experience any shear stress. Okay, now such a free surface is called the free surface of liquid. Okay, free surface of liquid, it is a surface. Now it is a free surface of liquid. Now this surface cannot experience any shear stress. Get it clear? Okay, so according to the molecular theory, 5 important concepts we have discussed. Now between this, first, intermolecular force, it is a force of attraction between 2 or more molecules. Now there are 2 types, cohesive force and adhesive force. Cohesive means what? The force of attraction between 2 molecules of same substance, and the force of attraction between 2 molecules of different substance, that is adhesive force. So after that we have discussed the range of molecular force. What is the range of molecular force? The maximum distance between 2 molecules up to which the intermolecular force is effective, and such range is 1 nanometer, that is 10 raised to power minus 9 meter. After that we have discussed the definition of sphere of influence. It is an imaginary sphere is drawn around the molecule whose radius is equal to the range of molecular force. So after that we have discussed the concept of surface film. It is a free surface of liquid whose thickness is equal to the range of molecular force. And finally we have discussed the free surface of liquid. It is a free surface, but that type free surface, they does not experience any shear stress. So all that 5 important concepts, you remember this, that is very important part according to the concept of surface tension. Okay, now after that we have discussed the force experience on a molecule on the free surface of liquid. Just imagine that the some molecules we are given, and between these molecules, so how amount of force experienced when such molecules are present on the free surface of liquid. So let's discuss the next concept for this chapter. Okay, the force experienced by molecule on the free surface of liquid. Okay, and such concept we are discussed with the help of an simple diagram, and with the help of this diagram we are trying to understand what is meant by surface tension. Okay, so let's continue the next point from this chapter according to surface tension. Okay, now the force acting on a molecule on the free surface of liquid. So we are discussed with the help of and simple diagram. So we are the force on a liquid on the free surface, and such concept we are discussed with the help of and simple diagram. So we are trying to draw the diagram. Okay, imagine that this is any one container. Okay, and just we fill the water between this container. So this is the free surface of liquid. Okay, this is free surface of liquid, and this free surface is represent x and y. So xy is the free surface of liquid. We draw one another parallel line. Okay, we are trying to draw one another parallel line. Okay, and such a parallel line will be represent x dash to y dash. So this distance between x to x and y to y, so this is denoted by r. So that is range of molecular force. It means the distance between x and x dash is the surface film. You got it clear? It is a free surface of liquid whose thickness is equal to the range of molecular force. So imagine that this is a surface film that is very thin. Okay, now then after we are consider 3 molecules. Okay, we are consider 3 molecules. We are trying to draw the molecules. There are 3 molecules. Now this is first molecule. Now then after, this is our second molecule. Now here we are at just the second molecule, and after that we are at just our third molecule. Okay, there are 3 molecules. So now the first molecule will be denoted by the molecule A, second molecule is represent the molecule B, and the third molecule is represent molecule C. Here observe the same, there are 3 molecules and such molecules are represent A, B, C. We are observe the same, the molecule A is well inside the liquid, it will completely deep inside the liquid. Now we are observe the same, the molecule B and molecule C. So this is the molecule. Okay, so molecule B is present within the surface film. We are observe the same, molecule B is present within the surface film and molecule C is present exactly on the free surface of liquid, exactly at the top of the surface of the liquid. You get it clear? And we are observe the same one by one all the molecules. Let's observe the first molecule A. Now molecule A and their sphere of influence is totally deep into the liquid. It means that for everywhere of the molecule A, okay, for everywhere of the molecule A, only the liquid molecules are attracting, only liquid particles. There is no another substance will be present. Okay, it means that the same substance molecules are attracting towards the molecule A in everywhere. So simply the molecule A experience the net resultant downward cohesive force, and with the help of this molecule A is well inside the liquid, because molecule A experience the net resultant downward cohesive force. The cohesive force experienced by the molecule A, because everywhere only the liquid particles are present, so they experience the cohesive force, and that's why they dip into the liquid. Get it clear? Let's observe the molecule B. When we observe the molecule B, now there are large part of the sphere of influence. There are large part of sphere of influence in liquid and the very small part of sphere of influence in air. But we know that the density of air is very small as compared to the liquid. So there are liquid particles and some weight of the liquid particles are very small as compared to the total weight of the liquid molecules within the sphere of influence. So that's why here the adhesive force between the air and liquid, okay, the adhesive force between the air and liquid is negligible, because according to the density, now the density of water is greater than air. So that's why the adhesive force between liquid and air will be negligible on the molecule B, and net resultant downward cohesive force is effective for that molecule B, and that's why they also dip into the liquid as per the density. Okay, now molecule A and molecule B both experience the net resultant downward cohesive force, and finally both are deep into the liquid. Let's see the molecule C. Now when we observe the molecule C is present exactly on the free surface of liquid, exactly on the free surface. Now the same condition will be applied on molecule C for molecule B. Okay, now we know that there are half sphere of influence in air and half sphere of influence in water. But as per the density, we know that the density of water is greater than the density of air. It means again the adhesive force between the water and air will be negligible on the molecule C, and molecule C is also experience the net resultant downward cohesive force, and finally the molecule C is only the liquid particles are attracting and they also dip into the liquid. Okay, finally we are observe the same molecule A, molecule B and molecule C. It means all the molecules, they lies on the free surface of liquid, they experience the net resultant downward cohesive force and finally dip into the liquid, and the free surface of liquid will be empty. Now when the free surface of liquid is empty, now such a free surface of liquid, when the all molecules are deep into the liquid, such a free surface of liquid behaves like a stretch elastic membrane. It means that the tension produces on the free surface of liquid and they behaves as like as a stretch elastic membrane. So such a tension on the free surface of liquid is called surface tension. Okay, now when the free surface of liquid behaves as like a stretch elastic membrane, so such such a free surface, they produces their own tension. So such a tension is called surface tension on the free surface of liquid. You get it clear, the concept of surface tension? Okay, because when all the molecules are lies on the free surface of liquid, and after that all the molecules are experience the net resultant downward cohesive force, and all are deep into the water, the free surface of liquid will be empty, and then after they behaves as a stretch elastic membrane, like a stretch elastic membrane between two sides. It means the tension produces on the free surface of liquid. So such a tension is called the surface tension on the free surface of liquid. That is very important. Okay, so let's discuss the definition of surface tension. What is the actual definition of surface tension? Let's imagine that this is a free surface of liquid. Okay, this is any one free surface of liquid, and between this, if the free surface of liquid is empty, we know that it behaves as like a stretch elastic membrane. So it means that this total free surface of liquid behaves a stretch elastic membrane. It means it will stretch between two different directions. It means it experiences the tangential force. It means the free surface of liquid is experience the tangential force. When the tangential force is applied on the free surface of liquid, now the total molecules on the free surface of liquid is experience the equivalent opposite force, and it behaves as like a stretch elastic membrane. Okay, so such a tangential force acting per unit length of the liquid surface in contact, so this is called surface tension. You get it clear? Such a tangential force acting per unit length of the liquid surface in contact, so this is called surface tension. So what is the definition of surface tension? Now let's see the definition of surface tension. The tangential force acting per unit length of liquid surface, acting per unit length of liquid surface is called surface tension. So let's see, the tangential force acting per unit length of the liquid surface is called surface tension. It means therefore the surface tension will be represent T. Capital T is the surface tension. So surface tension is equal to the tangential force acting per unit length of the liquid surface in contact. So this is called surface tension. So we can write here the surface tension T is equal to force per unit length. It means that T is equal to F upon L. Okay, so therefore T is the surface tension, and this is equal to the tangential force acting per unit length. So what is the SI unit of surface tension? So force is measured in Newton, okay, and length is measured in meter. So Newton per meter is the SI unit of surface tension. And what is the dimensional equation? Now we know that the dimensional equation of force, so that is L1 m1 and T minus 2, this is the dimensional equation of force. And the dimensional equation of length, that is meter, it means L1. So this L plus 1 take a numerator, so we get L minus 1. So this 2 will be cancelled, and we get the dimensional equation of surface tension is L0 m1 and T minus 2. Okay, this is the dimensional equation of surface tension. What is the unit of surface tension? Newton per meter, and dimensional equation is L0 m1 T minus 2. And what is the definition of surface tension? The tangential force acting per unit length of the liquid surface. So this is called surface tension. In shortly, you remember that the surface tension capital T is equal to F upon L. Okay, this is shortcut. Surface tension T is equal to force per unit length is called surface tension. Get it clear, the definition? Okay, this is our important concept. This is the next part from this chapter, surface tension. So I think you are good familiar about this. The very important concept, that is surface tension. So T is equal to F upon L. Get it clear? Okay. Now we are discuss the next important definition after the definition of surface tension. Okay. So we are trying to discuss the next definition. Now from the next concept is surface energy. Now when we discuss about the surface energy, we are trying to discuss one example, and with the help of this we are trying to discuss the definition of surface energy. Let's imagine that this is a container of liquid, okay, and when we take some liquid on the container, so we are observe the same. So between this we are consider there is a liquid molecules. Imagine that this is molecules are present on the free surface of liquid. Now when the molecules are exactly present on the free surface of liquid and it does not deep into the liquid, so it means that the gravitational force is acting for that molecule, but at this time these molecules does not deep into the liquid. It means it performing work against the gravitational force. When any object is performing work against the conservative force, against the force, okay, now such work is restored in the form of energy. Such energy is called potential energy. You remember this. What is the potential energy? So potential energy is the ability of that substance to do some work against the force. What is potential energy? Potential energy is the ability for that substance to do some work against the force. You get it clear? So then after the potential energy will be stored for that object. Now when molecule just present on the free surface, it cannot deep into the liquid, it means they performing work against the gravitational force, and such work is restored in the form of energy. So such kind of energy will be potential energy. Okay. Now it means that when the molecules are present exactly on the free surface of liquid, now it has an extra potential energy. But if the molecules are deep into the liquid, now their molecular energy will be decreases. It means the molecules having maximum amount of potential energy when the molecules are present on the free surface of liquid. That is very important. Now such extra potential energy for that substance on the free surface of liquid, okay, now such extra potential energy of the molecules on the free surface of liquid area, so that is called potential energy per unit area, that is called surface energy. The extra potential energy for that molecules on the free surface of liquid, okay, such extra potential energy is called surface energy. You get it clear, the concept of surface energy? Okay, surface energy means what? The potential energy per unit area of liquid surface. Okay, so now potential energy per unit area of the liquid surface is called surface energy. It means the surface energy is equal to potential energy per unit area. It means what? Surface energy is the potential energy per unit area. But actually we know that what is meant by potential energy? When the molecules are performing work against the gravitational force. Okay, so then after it has a maximum amount of energy. Such restored energy is called potential energy, and potential energy is the ability for that substance to do some work against the force. Okay, now when these molecules are exactly present on the liquid surface, it does not acting towards the gravitational force, so it means they performing work against the gravitational force, and such work done is restored in the form of energy. Such energy is called potential energy. It means that the potential energy is also called work, and that's why the expression for surface energy we are also represent the surface energy is equal to potential energy per unit area, otherwise work per unit area, okay. So potential energy per unit area, otherwise work per unit area, so both are same, okay, that is called surface energy. Okay, the concept is clear. Surface energy means what? The extra potential energy of the liquids on the free surface of liquid. So this extra potential energy is called the surface energy of the molecules, surface energy of the liquid, sorry. Get it clear? Okay, all the concepts are clear. So which concepts we are discussed according to the chapter of surface tension? Now the first important concept we are discussed their molecular theory, And with the help of molecular theory, we have discussed some important definitions like intermolecular force. There are two types, cohesive force and adhesive force. After the range of molecular force, sphere of influence, surface film and free surface of liquid. And after that we have discussed the very important concept, the definition of surface tension and surface energy according to their molecular theory. So get it clear? All the concepts are clear? We are remember that the definition of surface tension and surface energy. What is surface tension? The tangential force acting per unit length. Okay, tangential force acting per unit length is called surface tension. What is the unit of surface tension? Newton per meter. What is the dimensional equation of surface tension? L0 m1 t minus 2. And what is the surface energy? Surface energy is the potential energy per unit area of the liquid surface. So that is called surface energy of the liquid surface. And surface energy is measured in joule. Joule is the SI unit of surface energy, and their dimensional equation is L2 m1 t minus 2. This is the dimensional equation of surface energy. Okay, so all the concepts are clear. So let's discuss the next concept, that is very important concept, the relationship between surface energy and surface tension. Okay, so let's discuss this concept in next lecture. So we are stop here.